Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 18. Today we're going to talk about parallel lines. We'll construct parallel lines, and then we'll also do an algebra review with parallel and perpendicular line slopes. Parallel lines are lines that lie in the same plane and do not intersect. This is a picture of intersecting lines, so we know that they're not parallel. Here's a picture where the two lines don't intersect on the page, but if we kept drawing them, they would eventually intersect together somewhere out here. Now here's a set of lines that look parallel, but how do we know for sure that they are? One way to check that two lines are parallel is for us to draw a transversal through it and compare the corresponding angles. Think back, what should corresponding angles be if the lines are indeed parallel? Hopefully you said that they would be congruent. We're going to construct parallel lines by folding. First, we'll draw a line and a point not on the line on some kind of patty or tracing paper. Then we'll fold the paper easily to construct a perpendicular that runs through the point and perpendicular to the line you have drawn. We'll talk about the new angles that you've formed. Through the point, we'll make another fold that is now perpendicular to the first crease. We'll look at the corresponding angles created by the folds. Are they all congruent? If they are, what conclusion can you make about the two lines? So let's watch this video and see. We have a line and a point, and we're just going to fold this. Remember, we're trying to get the fold where the lines are on top of each other, and the fold is right on that point. When we unfold it, we'll draw a new line in that crease, and that line should be perpendicular to the original line. I'm going to draw mine in a different color just so I can describe it. So now I have a green line that's perpendicular to the black line. I'm going to fold my paper again, this time matching the green lines and having the crease right at that point that I had. When I unfold it, I'm going to draw in that crease. So how do the two black lines compare? If I get out a protractor, I can measure the corresponding angles. So this top right angle is 90 degrees, and so is the top right angle in that one. Our top left one also measures 90 degrees, and our top left one in this intersection is 90 degrees. Because those are corresponding angles and they match up, they are congruent, then we know that these two lines are parallel. So the patty paper method was fast for constructing parallel lines. It could have been done with a compass and a straight edge. Remember that we kind of use how we would get a perpendicular bisector by putting 2 points on the line to help us, but we could do it with a compass and a straight edge. We use corresponding angles in this investigation, but we could have also duplicated alternate interior angles or alternate exterior angles to construct parallel lines. We could construct two perpendiculars to the same line. So your homework is going to have you practice all these different methods on constructing two parallel lines. Now let's talk about the slopes of parallel and perpendicular lines. How do slopes of two parallel lines compare? And what about perpendicular lines? So first, we're going to draw on this grid two lines with the same slope. So I'm just going to pick a point here, and I'm going to make this slope 3, 1. So my rise will be 3 and my run will be 1. And I'm going to get another point by going down 3 and backwards 1. And so now if I connect those lines, now on the computer, I don't have a straight edge, so they're not as good. Here's my first line, line 1, or we'll call it A, line A. So now I'm just going to start anywhere else, and I'm going to do the same slope. So I'm going to go up 3 and over 1, up 3 and over 1, up 3 and over 1, and then I'll go ahead and do 1 down. And now I'm going to connect these points to make a line with the same slope. So how does A compare to B? Well, they look parallel, right? So actually, that is the definition in coordinate geometry. In a coordinate plane, two distinct lines are parallel if and only if their slopes are equal. So we just drew two lines with the same slope, and they were parallel. You could try on your grid paper something different than mine and make sure that yours are parallel. Now, what about perpendicular lines? If two lines are perpendicular, their slopes are going to have a very different relationship. Let's look at this picture of two perpendicular lines. What is the slope of the red line? Well, we can see that it's a rise of 3 and a run of 2. So the red line is rise over run, the 3 over 2. What about the purple line? What's the slope there? Well, my rise is 2 and my run is 3, but my run is going to be is a different direction. So it's 2 over 3, but I can see that it's a negative slope. This purple line is going downhill. If I go from this point to this point, I'm going down 2 and forward 3. So I know that one of these is negative. My slope overall will be negative. So I have the red line going uphill and the purple line going downhill. The red slope is 3 over 2, and the purple slope is negative 2 over 3. How are these related? Well, the perpendicular slope property says in a coordinate plane, two non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. So hopefully you remember from algebra that a reciprocal would be what you multiply something by to get 1. In the case of fractions, if you just flip the fraction, that would be the reciprocal. And these slopes are also opposite signs. So if one is positive, the other has to be negative. So here's that picture again. Why do the slopes have opposite signs? Well, in this case, we can see our red line was positive and our purple line was negative. But even if we were to rotate this, you always have to keep 90 degrees between two perpendicular lines. And so they're always going to form that X. No matter how I rotate that X in the coordinate grid, one of them is always going to go up and one's going to go down. That's just how the lines are constructed. So one of them is always going to be positive with the other negative. These slopes will always have opposite signs when they're perpendicular. Do you see why they have to be reciprocals? When they're 90 degrees apart, it's going to swap the direction of the X and the Y's, right? The X goes out and the Y goes up. If you were to swap those, that would be the opposite or the reciprocal of, and that is what the 90 degrees or the perpendicular lines will form. And why does the property include only non-vertical lines? Well, what's the slope of a vertical line? What's the slope when you have one right here? The slope is undefined. So we couldn't say what the negative reciprocal is because this slope is undefined. So that's why we talk about it being only non-vertical lines. If it was exactly vertical, we wouldn't have a slope. So we couldn't say that the slopes were negative reciprocals. That's it for this lesson. See you next time.